In this video, I'm going to explain to you the concepts of acceleration and velocity. I've got many students who can sort of understand what velocity is, but when it comes to acceleration, they're a bit more uncertain about it. So let us first start off by looking at the definition of acceleration and velocity, as you can see on the screen. Okay, acceleration is the rate of change of velocity, while velocity is the rate of change of displacement. So just by looking at the definition itself, you know that the concepts of acceleration and velocity is actually very similar. The only thing is the quantity that they are measuring. For acceleration, they are measuring the rate of change of velocity, while velocity you are measuring the rate of change of displacement. So the key to understanding acceleration and velocity is to understand what it means by rate of change of. Okay, so what rate of change of means, right, is basically, to put it in simpler terms, is how fast something changes. So in other words, acceleration measures how fast velocity changes, and velocity measures how fast displacement changes. Okay, so let's just start off by looking at velocity first. Remember, I said velocity measures how fast displacement changes. Okay, so let's take an example of a ball which is traveling at velocity of 10 meters per second, and the moment it passes this point, we start our stopwatch. So the stopwatch will read time equals to 0 second. Alright, so at time equals to 1 second, the ball would be probably somewhere around here, and because the velocity is 10 meters per second, right, you know that the ball covers a distance of 10 meters every second. Displacement here would be 10 meters. Okay, so what happens at time equals to 2 seconds? Again, we'll expect the ball to be somewhere around here, and the distance between time equals to 1 second and time equals to 2 seconds, this will be another 10 meters, right? Because a velocity of 10 meters per second means that it travels 10 meters every second. Okay, but what is the displacement at time equals to 2 seconds? Displacement is always taking reference from an initial point, right? So the displacement is actually 10 meters plus 10 meters. Okay, what about time equals to 3 seconds? This is the ball again. This will be 10 meters, but the displacement would be 30 meters. So what you can see here is velocity with a velocity of 10 meters per second, displacement increase by 10 meters every second. Remember, look at the definition again. Velocity measures how fast displacement changes, and with a velocity of 10 meters per second, displacement increase or change by 10 meters every second. So at time equals to 0 second, displacement equals to 0 meters. Time equals to 1 second, displacement equals to 10 meters. For 2 seconds, displacement is 20 meters. And for 3 seconds, displacement equals to 30 meters, and so on and so forth. But what you can see that every second, there's an increase of 10 meters in displacement. Okay, so remember this concept, and we'll see how acceleration is very similar to this. Okay, let me just write down what acceleration measures. Acceleration measures how fast velocity changes. So remember, previously, instead of velocity, it was displacement, right, for the case of velocity. That was in the previous case, okay? But now for acceleration, we are measuring how fast velocity changes. So again, let's take the example of a ball with an initial speed of 10 meters per second. It's accelerating in the forward direction at a rate of 5 meters per second squared. So what's going to happen is we are going to start a stopwatch when it's traveling at 10 meters per second. So at time equals to 0 second, velocity is 10 meters per second. Correct? This is our initial starting conditions. And at time equals to 1 second, velocity is with an acceleration of 5 meters per second squared, it means that velocity increased by 5 meters per second every second. Correct? Because acceleration measures how fast velocity changes. So at time equals to 1 second, velocity is 15 meters per second, an increase of 5 meters per second. Time equals to 2 seconds, velocity equals to 20 meters per second, with an increase of 5 meters per second again. Okay, and so on and so forth. So what you can see here is that acceleration is actually very similar to velocity. It's just that in velocity we are talking about how fast displacement changes, whereas in acceleration we are talking about how fast velocity changes. I also like to explain to my students that acceleration, velocity and displacement, these three concepts can actually be understood as three different levels. The lowest being displacement, followed by velocity, and finally acceleration. Okay, so what do I mean by three different levels? We know that displacement, the units of displacement is in meters, right? And the units of velocity is meter per second. The units of acceleration is meter per second squared. Okay, so what's the difference between each step? To get velocity from displacement, you are dividing by second, right? Okay, not really dividing by second, you are dividing by time. Correct? So you get a formula, velocity equals to displacement over time. Okay, to get from velocity to acceleration, you again divide by time. That's why acceleration is velocity over time. And one cool thing you can tell from the units itself is actually the definition of acceleration and velocity. So if you look at velocity, is meter per second, right? Meter per second. Meter is displacement. Second is time, right? So just by looking at this like this, you know that velocity is measuring displacement with respect to time. So how fast displacement changes with time. If you look at acceleration, meter per second square can be rewritten as meter over second square, which is the same as meter per second over second. And the numerator is just velocity and the denominator is time. So again, just by looking at the units, you know that acceleration is a measurement of the rate of change of velocity. So how fast velocity changes with time. Yeah, so this is just an info for you, so sort of bring everything together.